Hello, everyone, and welcome to RCC's Introduction to Linux workshop. Just as a quick introduction, my name is Alex Townsend. I'm a scientific applications specialist and one of the members of the software team at the Research Computing Center. My co-presenter is Brian Gentry. He's one of the systems administrators on the systems team of the Research Computing Center.
Hello.
So together we'll be presenting this workshop. I'll be doing most of the conceptual overview, and Brian will take you through the practical Linux tutorials and the practical Linux command. The overview of this talk is that we're going to go over a few different concepts. We're going to talk about what Linux is, and what operating systems are, and a little bit about file systems. These are sort of the big three concepts you need to know to get started with Linux, and they're three of the most important concepts that apply to pretty much any operating system. And then along with that, we're going to take you through a tour of the Linux terminal, and we'll show you a lot of really important commands in the Linux terminal and how to use those. So, what is an operating system? If you're familiar with Linux, or if you're familiar with Windows or Mac or something, you've all used an operating system. It's basically the system it's basically the thing that comes up on your screen whenever you turn on your computer. You get the little Windows logo, or you get the little Mac logo. Essentially, what an operating system is it's a program, or really nowadays more of a suite of programs that act as a middleman between the user and the hardware. So it's a set of programs that mediate your interaction with the actual bits and bytes and the actual circuitry on your hardware. It's also the main logistics center of the computer. So it's the program that's going to handle allocating of memory on your computer. It's going to handle switching in and out, switching between different tasks, and it's going to handle all of the really repetitive memory and low-level tasks that need to be done in order for you to use your computer kind of how you do every day. It also handles modern operating systems nowadays also tend to handle things like efficiency and power management. If you're on Windows or Mac, you might see there's often a little button on the bottom right hand of the screen which says which has a little battery symbol if you're on a laptop, and you can control a little bit about how the operating system uses the battery, and that tends to affect things like the backlight and things like that. It's essentially the operating system is the supply chain manager of the computer. It takes requests from you, the user, saying, okay, what do I need? Or what do I want to do and what do I need? And then it will go to the hardware and say, okay, I need these resources, and these resources, and then it will take those, orchestrate them, and present them to you in a way that's usable. There are many, many different operating systems. Windows is by far the most common and most widely used in business today. But Linux is actually the most commonly used for scientific applications and in high-performance computing systems. So it tends to be really useful to know both, especially if you're doing scientific research, or if you're doing research that involves, or if you're doing research or work in general that involves really big computational systems. A lot of those systems tend to be written for Linux nowadays. There's also iOS. If you have an iPhone or an iPad, that is its own operating system. There's a number of other ones that you may never have heard of, like BSD, Solaris, and easily half a dozen others. So what is Linux? Linux is an open source operating system, and in fact most of the distributions of Linux, but not all, are both free and open source. So you can actually go to their website, download the operating system, and install it for free. It's built upon an older system called Unix, and it is fundamentally very different and incompatible with Windows. The file structure that it uses is very different from Windows. The system commands that the operating system uses to interact with the hardware are very different from the ones Windows uses. like I said, it is commonly used in scientific computing applications. If you've ever worked with a supercomputer, or if you've ever worked with a lot of or you've ever worked with really big computational systems, a lot of those programs are either written for Linux, or they're written for Linux and then have a Windows compatibility layer. So there's another couple of important concepts with operating systems to know is the difference between a graphical user interface, or a GUI, and a command line interface, or a CLI. Graphical user interfaces are what you're probably most familiar with. If you use Windows or Mac, or even most flavors of Linux nowadays, a graphical user interface is that's the point and click. You take your mouse and you go and click on the application or the file you want. A command line interface is basically just a screen with a prompt, and in that prompt you have to actually type commands, and you don't have mouse interaction at all. So Windows. So this slide used to be a bit. Oh yes.
I have a question.
Yeah.
Like, if you did something in the command line, like, say you created a folder, whatever, would you see that in the, like, are they kind of like, you know what I'm saying? Like, will a folder in the command line that you create show up in the GUI?
Yes.
Screen?
Yes. So the the GUI graphical user interface is actually just a layer in front of the command line most of the time. So most anything you do in the graphical user interface will be reflected in the command line, and vice versa. So this slide used to be a bit more true than it is nowadays. Linux used to be a primarily command line interface. Nowadays there are distributions of Linux like Ubuntu and Fedora that have really, really good graphical user interfaces. Windows is primarily a graphical user interface program. Generally, the way I think about Windows is if you see the command line on Windows, something bad has happened. Usually something really bad has happened. On Linux, you pretty much can't even though there's really good graphical user interfaces, you really can't get away from the command line. And if you're going to be doing any sort of research or work with scientific or modern scientific tools, or you're going to be doing like graduate school research, you're probably going to need the command line sooner or later. So another big difference between Windows and Linux is that Windows tends to be Windows is a proprietary and often very expensive operating system, and it's the way that it does its releases, the way that it updates itself and does its distributions is very linear. You have Windows 95, and then a couple years later you have Windows 98, and then a few years later you have ME, XP, 7, 8, 10, and nowadays 11 and 12. And those are linear updates. With Linux, it tends to that still exists, but also with Linux, distributions tend to break off of each other into this big tree-like pattern. So for example, there's a system called Red Hat Enterprise Linux, but off of that is also but something that's based on that is also a distribution called CentOS. There's also a distribution that's based on Red Hat called Rocky Linux. There's also a distribution called Alma Linux, and the same thing is true of another totally different distribution called Debian. Debian has branches off of it for things like Ubuntu, Linux Mint, and half a dozen others. And this branching and tree-like structure of how Linux tends to evolve over time really is due to the fact that it's open source. So even though you'll still have things like Ubuntu 18, and then a few years later Ubuntu 20, a few years later Ubuntu 22, somewhere in there, because the operating system is open source, some company or some group of people could say, hey, I like Ubuntu, but I want to make a distribution that's a little bit different. So they can actually take a copy of the source code and modify it and create a new distribution. So as a result, there are many, many, many different Linux distributions. They all fundamentally have many similarities, but there are also many differences. What we're going to show you today are the fundamentals that you can pretty much expect to see in any Linux distribution. So, are there any questions or Anything? Are there any questions before we move on? Yes.
What's your preferred version of Linux that you like?
I tend to use Fedora. At RCC, we use CentOS, and in the future we're going to move to Alma Linux, and those are all very, very similar distributions. Fedora is either based on Red Hat or a little bit upstream of Red Hat, so they're all basic. They're all in the same family. That's just the one I tend to use. Fedora is nice.
A follow on it.
Yeah.
Like, is there a specific version of Linux that you would recommend for users over others?
If you're just getting so it depends on whether you're. Did you have something, Casey? Oh, so it depends on what you're going to do, what you're planning to do with Linux. If you're planning to interact with, like, an HPC system or something, you're probably going to want Fedora right now, because Fedora is a really good desktop distribution. The two really, really good ones that I know of are Fedora and Ubuntu. They both have a lot of history, and they're both well supported, and they both have good user interfaces.
For programming? Like, if you
Yes.
want to program the same?
Oh yeah.
Okay.
Yes, both of them are very good for programming, and they both support pretty much all the same things you would need. Are there any other questions? Anyone online? Okay. In that case, we will move on to concepts about the file systems, and that will be Brian Gentry.
Hey everybody. So it's our next slide here. Okay. So all file systems are kind of the same. If you've used Windows Explorer and looked at your C drive, you've seen a file system. It all starts at a single point and branches off into directories, and directories have files in them. This is almost obvious today if you've used any kind of computer. Linux is the same way. It's just handled a little differently. Okay, I guess I just said that there. Starts at the root and branches off. In Linux, slash is the root of the file system, and everything starts there. So if you have multiple drives, which I'm about to get to, they're all mount points on slash, as opposed to C:, D:, E:, P:, which I guess is this right here. So this is what you'd expect to see for your drives on Windows, drive letters. And on Linux, well, this isn't set up the way I thought it was. So in Windows, I guess you see little images of your disks. Or in Linux, it's not as obvious where the drives are. It's all one unified system. Because generally speaking, when you're on the HPC in particular, you kind of don't care what drive is what. You care what you have access to and where you're supposed to put your stuff. And you normally will know that. Your home directory is assigned to you only. You're the only one who has write permissions in your home directory. And that's where you'll do a lot of your work. If you're part of a research group, you will probably have access to the research group's specific area on our system called GPFS. And GPFS is just another directory on all the systems. And any of the systems you go to will have all the same files in all the same places, including your home directory, including all the research directories. And we're going to show you how to navigate that and get around. So here's kind of an example of what you might see on a typical Linux system for where the drives are. MNT SRV for a server mounted from a network, /drive for another hard drive, /media/USB for another, like a USB thumb drive you plug in. This is more applicable on a desktop system, again, where you care about what drive is what. On the HPC, you're going to kind of start to memorize the paths, /GPFS, /research, /stag. This is where Scott Stagg's groups files are located. GPFS research coapps, this is where the coapps files are at. And you'll know your home directory because it's just GPFS home and then your username. In my case, it's GPFS home bgentry, and that's where all my files are located. All of you will have your own. Let's see here. This is an important distinction. In Windows, we separate our drive path, our folder paths, like documents, workshops, presentation, with a backslash. And in Unix variants, it's always a /. So this takes a little getting used to. But for me, it's easier for my finger to hit the slash than the backslash. Backslash is kind of a big reach up on the keyboard. So it's actually easier to type. If you start typing backslashes and it doesn't work, Just remember, it's slashes.
That was a little bit about operating systems and file systems. They both interact. A file system is generally part of an operating system. The next big concept we need to introduce is something called the Linux terminal. So you may hear a bunch of different terms that all kind of mean the same thing. If you hear command line, and now that I'm thinking about it, I've actually used several of these terms. So all of these terms on the screen mean the same thing. If you hear shell, if you hear terminal, if you hear command line, they all essentially mean the same thing. And the way that the terminal interacts with the system is kind of in this hierarchy. You as the user outside the computer will type in some commands and give user input to the terminal as in the forms of commands and command arguments and things like that. And then the terminal will take those and interpret those into commands that the operating system understands. And it will say, okay, operating system, go do X, Y, and Z for me. And then the kernel, which is the core part of the operating system, will go off and perform on the hardware whatever commands the user asked it to do. And then once the hardware is done, it will report. Once the hardware and the system are done, it will report. The kernel will report the results back to the terminal, which will interpret them and print them back out for the user to see. And this cycle of interaction is pretty much how the command line works. You give input, the terminal interprets your input to something the operating system understands. The operating system goes off and does it, and then it will give you back the result. The Linux terminal is pretty much the main point of interaction for Linux and Linux-like operating systems. If you're going to be doing programming at all, if you're going to be doing software development, you're going to have to interact with the command line. If you're just using if you're just using Linux for like basic day-to-day word processing, you may not need the command line. But for pretty much any big-time research, or if you're going to be installing most packages, you're probably going to want the command line. So another thing to note is that Mac and Linux terminals are actually very, very similar. And correct me if I'm wrong, Brian, but that's because Mac and Linux are both POSIX compliant.
And they're both based on Unix.
Yeah, and they are both based on Unix. Mac OS and Linux are actually both themselves branches off of the old original system called Unix. So as a result, they are both what's called POSIX compliant, and POSIX is an acronym for something I don't remember, but it is essentially a standard which defines what set of system calls and what set of operations need to be supported by the operating system. And anything that's POSIX compliant will most likely have terminals that are very, very similar. So, as I said, the purpose of the Linux terminal is for you to issue commands to the operating system. The terminal will also provide utilities for you to monitor the health and operation of the system. You can also use the terminal to log in remotely to other systems through something called Secure Shell or SSH. So that's basically what the Linux terminal is. It's basically just a screen with a prompt that lets you issue commands and gives you back the results. Are there any questions before we move into actually how to do commands on Linux?
The question in chat, Ali asked, she asked me how they can join the research group.
So in order to join a research group, that's a question that should be posed directly to RCC. So please send that question to support@rcc.fsu.edu, and I'll make sure that our moderators post that in the chat, especially for questions like that, because that needs to be done through the RCC team.
So when you first start using the command line, it's gonna seem weird. It's gonna seem slow, it's gonna seem old, and at some point you're gonna wonder why you're doing this. This is one of those things where the learning curve is steep, but the payoff is huge. Once you gain some skill with the command line, you're gonna find that you're doing things in a different way that you almost can't do graphically. It's not that it's impossible, but the command line gives you sort of in a way, it's weird because it's really basic, yet it allows you to do really advanced things once you've kind of gotten over the hump. I think what a good example of this is. In a way, this is like learning to drive a manual transmission car. It's harder, but it gives you more capabilities than an automatic. You can control your exact shift points. You can slip the clutch. You can heel toe. You can do all these things that you can't do in an automatic. And it goes way beyond that with a command line, but it's, I know that psychologically when you start to learn something like this that has a steep learning curve, you got to know that there's a payoff at the end. And there definitely is once you gain some skill with the command line. A lot of these things are going to be about moving around in the file system and working with files. You're going to launch programs from time to time, but a lot of what you do is going to be either finding files, editing files, viewing files, creating directories, doing organization. And we're going to get to all these topics: navigating, finding, viewing, deleting, creating, editing, and how to get help. And I'll give you the preview on getting help. It's mostly Google what you're after. So commands on the command line. They break down into the command name itself and into arguments. And rather than making this all academic, and I'll let you stare at this slide for just a moment, and then I'm just going to show you this command and tell you why it does what it does. So that command was ls minus, I think, al, and there was an argument at the end, which was the file we were looking for. So ls means list files. Show me all the files in my directory. And if I type it all by itself, you can see it gives me a very short listing. When I do the longer version, the A means show me all files, which I'll explain in a moment, and the L means give me a long listing, which you can see I've got this much longer listing that shows me the ownership of the files. It's B Gentry on both of them, that's me. Shows you some stuff off to the left, which I'll explain in a minute. And of course the modification date, and that weird number in the fourth column is the size in bytes. So what's this A? What is this all files? I thought files were files. Well, in Linux, they've sort of divided files into two separate categories. One is files that are regular. If I touch file 1 and I touch file 2 and I do an ls minus al, there's the, whoa, I'm in the wrong place. Just a moment. All right, so hold on a second, I'm messing up here. Okay. So, ls in this directory, I see file 1 and file 2. But if I do an ls minus a, I see another file, dot file. Linux and Unix divide files into two groups, regular files and files that start with a period. So the A means show me those files with a period in them. You're going to need to do this from time to time because in your home directory, you're going to find quite a few files that start with dot. Let me take that L away to make this more clear. These are mostly configuration files. It'll be things like your .bashrc. Let me see if I can actually show these. Boy, they're all symlinks. So that .bashrc, for example, is the configuration file for the shell that I'm running. And the vimrc is the configuration file for Vim, etc. So you don't always need to see these, but it's nice to be able to show them when you do need them. So back to our slide for a moment here. So you can also give ls arguments. For example, I'm here in my home directory, but if I want to ls my source directory, which is underneath it, let me just show you the whole thing. You can see src right there, about a third of the way down on the right. If I want to ls the src directory, there's everything that's inside the src directory. That's an abbreviation for source or source code, and most of this is source code that I've written or edited or something like that. That was probably quite a mouthful of stuff I just gave you there. Any questions before we move on? Yes?
So if they were to do ls-l on their directory right now, what would show up?
Very little. I think there'll only be one file in your workshop directories. I guess it's a great idea for them to do that. Thank you. So try an ls-l and see what you see.
What does the L stand for again?
Long listing. So if you do ls by itself, you'll get a short listing without the details. And if you do a long listing, ls-l, you'll see all these extra things, the owner, the size, the date, and the permissions. Does everybody see something in their home directory? Okay. I'm hoping you see the playground. Okay, we're going to go play in a little bit. And we're going to play in the playground. Okay, so back to the slide. I guess we're going to move to the next one. Okay, so again, this is sort of a technical explanation of what these things are. You know, the first thing is the command. The second two things are options or switches. Options or switches always start with a dash, and a lot of Unix people will say minus, so you'll hear ls minus al. And what they mean is ls space dash al. You'll hear that a lot. And then, of course, the final thing is any argument to this, which, again, a demonstration coming up soon will maybe make these concepts more clear. Okay, so here's a little bit of a dump of a few commands that we can run. Who am I to tell you who you are? This seems silly. Like, why would I need to know who I am? Well, when you just start and you don't know what username you've been assigned because it's 3 digits and 2 numbers, it's really nice to be able to type who am I and get your exact username. Host name is sometimes useful because the RCC has roughly 1,000 Linux machines, and you may end up on many different Linux machines. In fact, when you dispatch your HPC jobs, they can go to one of hundreds of different machines, and occasionally you'll need to use a hostname command in one of your jobs to identify what machine you're on. This is primarily a troubleshooting thing, but the hostname command is nice to have. Date shows you the date and time. Free you won't use much, but it's kind of fun. It shows you how much RAM is on the system, how much RAM is being used, and how much RAM is free. DF's another one you probably won't use much. This shows you things about disk space. You may end up touching DF at some point. And the most important command on this whole slide for me is pwd, print working directory. Where am I? In fact, a lot of what we're about to do, I'm skipping ahead again, I'm sorry. A lot of what we're about to do is kind of like navigating a map in a game. And you need to know some things. How do I find out where I am? pwd. How do I see what's around me? ls, we've just done that. How do I go somewhere else? You're about to learn the cd command. And how do I get back home so I can start over again? I'm going to show you how to do that too. So next slide. Hey, I guess I've already done this. ls and cd, very important. So cd just takes a directory name as an argument, and it takes you to that directory. If you've ever been in a DOS terminal, this is identical. In fact, in a DOS terminal, you have dir, dir. Dir and ls are almost identical. Ls is more powerful, it takes more stuff, but it's really, really similar. You're going to be using cd and ls in your sleep. You're going to be using it just all the time. So I guess we're going to break down actually what we're seeing here. So rather than do Mr. Slide, I want to use a real example. So we're going to look here at this very last line that says view.py. So if we start from the left, the first thing is the permissions. The second thing you can kind of ignore, it's the link count. The next two are the owner, that's me, bgentry, and the group, which is my personal group that nobody else is a part of. That's kind of a weird thing. You may sometimes or frequently see the name of your research group. For example, if you're part of the CoApps group, your files maybe have a group owner of CoApps, which means that you can share with your group, read and or write permissions on your files. And this can be really important when you're in a shared directory so that people can read what you're doing and you can read what they're doing. The next thing is the size in bytes. Finally, we've got the modification date and time, December 16th, 2021, and the name of the file, view.py. That is a Python file, py. Just for fun here, this is kind of unfriendly, the size in bytes, and a lot of times you're trying to find really big files. So you can make this human readable. I'm trying to enunciate these first characters when they mean an argument. So long listing is L, human readable is H. We're going to do human readable. And look, we've got a much more friendly human readable thing here. We've got 211K, 4K, 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 16K. So this is much easier than trying to count zeros and count decimal places. So this is just kind of a basic thing you can add to LS. LS has dozens of different switches. You're going to use 3 or 4 of them all the time. LS minus AL, LS minus H, and that kind of thing. Yes, sir?
For the dates on there, is that the date it was created, or the date that was last modified?
Pretty sure it's last modified. I'm going to skip ahead and teach you a new command to test it because I can't remember. So the touch command updates the date on a file to right this second. Hey, I touched you. Or if you give it a file name that doesn't exist, it creates that file out of thin air. It doesn't have anything in it, but it creates it with today's timestamp. So we're going to touch view.py, and then we're going to do that same ls command. Yep, and it updated it to today and the time. And if I do date, yep, in fact, it's 1541, just like it said. You may notice that I'm doing something else here, that I'm bringing up my previous commands really quickly. I'm using the up arrow on the keyboard. And it lets me go through my entire history of all the things we've done here. Remember all this? And I guess I should show you one more thing while I'm here. You know, I'm in the middle of this thing, and I've gone up arrow like 1,000 times, and now I'm trying to go down to get back to just a blank command line. Well, I can get to a blank command line, and in fact, I can cancel almost anything in Unix by using Control-C. So hold down the Control button and press C. Oh, that's not the Control button, that is. There we go, and it cancels my command. Control-C will also cancel almost anything that's running. You're going to use Control-C quite a bit from time to time also. All right, back to the slides. I should say, any more questions on that? Nothing from Zoom? Awesome. All right, next slide. Okay, so we're going to break down permissions now. So I guess we do have a little directory listing we can look at down here. So we're only talking about the first column here, that group of blah, RWXD, blah, blah, blah. So let's go back to my shell, and let's do another ls minus lh. So let's look at this very last file, that starts, the view.py again, that starts with a dash. So notice the file right above it doesn't have a dash, it has a D. That means it's a directory. And notice it's colored differently too, to try to cue you visually that that's a directory. So that's easy. If it's a D, it's a directory. If it's a dash, it's a regular file. And if you've already done your ls in your terminal, you might notice that Playground has an L. L means link. That is a shortcut that takes you to another part of the file system. So D, L, and dash is normally what you're going to see there. Now here's the important ones. The next 3 groups of characters, RWX, RWX, RWX. Each group of these, RWX, the first one is it readable? R. The next is it writable? W. And the next is it executable? Is it a program that I can actually run? And am I going to allow myself to run it? If executable is set, you can run it. This is maybe a bit of a departure from other systems you're used to, where, well, programs just run. We write a lot of scripts and a lot of interpreted language programs under Unix. So Perl, Python, Bash Shell, Corn Shell. That's all I can think of right now. But all these are interpreted languages that don't need to be compiled, and they don't produce binary output. Instead, you just write the program and set the execute bit and type its name, and it runs. And if there's errors, it lists the errors, and if it's not, it lists whatever output you told it to do. So read, write, execute. So you'll notice that very first one has RWX for the first group. That first group is the owner. That's me. I can read it, I can write it, I can execute it. The next group, R-X, that is for the group. So if we pretend that I was in a research group, in this case called staff, everyone on staff can execute it, they can read it, but they can't write it. They can't change it, they can't delete it. Because it's mine. I don't want somebody to modify it. And the third group is exactly the same, but it's for everyone else. So we kind of got this, this three-legged stool of permissions. We got you, the group that owns it, and we got everybody else. And you can't do all the permissions in the world with these three things, but you can do a lot. And I think it's kind of obvious. If you're in one group, you can make those files owned by that group. And you can change the group to any group that you're in. If you're in, say, two research groups, you can have some files owned by one research group and some files owned by the other research group. I say owned by, what I mean is group ownership. Because as you can see on screen, every file has two things. It's got an owner and it's got a group. The first column is the owner and the second is the group. And those correspond directly to those permissions that are there. Permissions can be a little bit intimidating, but you should really get to know them because they're a really fundamental part of how you manage your files. Yes, sir.
So online, when you try to access certain pages, I know about .html files and stuff like that, but I mean, like, is this kind of where you would change permissions if you're allowed to look at a certain page?
It's a good analogy. For sure, it's a great analogy for sure, but it doesn't have a one-to-one relationship. Generally speaking, on a web server, the server itself controls access by the person that's logged in. So it doesn't have a one-to-one relationship, but it is the exact same concept. So you've got the concept correct.
On the server, this would happen.
Generally speaking, it's an internal database, and there aren't any permissions on disk that map directly to the permissions on a website. But the concept's identical. Segmenting access by user. Yes, sir?
What's X means when you have a directory?
Thank you for reminding me. I really meant to say that, and I forgot. So this is a little odd. So X on a directory means you can CD into it, which means you can do some really weird stuff. You can set up a directory that's readable, but you can't go into it. You can set up a directory that you can CD into, but you can't read anything. This is not commonly used, but occasionally you want to have a parent directory that has a bunch of stuff in it that you don't want anyone to see directly. And below it, you want folders that people can see. I don't do this very often, but I've been doing Unix for about 30 years now. And a dozen times or so in my career, I've needed to do that where a parent directory is not readable, but you go through it to get to the directory you want. Uncommon, but it's there. Just know that on essentially every directory you make, you're going to want to have read and execute permission for anyone that needs access to it. Okay, I'm going to go to the next slide. Oh, and this kind of summarizes what I said: owner, group, other. Let's just stare at that for just a minute to kind of internalize that. It's not on this slide, but I'm gonna get a little advanced on you just for fun. I'm sorry. Zoom question.
No, just a general heads up that these slides will be available after the presentation. So if there's a lot of information on it and we're going through it a little bit quickly, know that you'll have this after the workshop.
I'm very new to this, so I didn't know that, and I'll sarcastically say that's a fantastic idea. All right. So next here. Yeah, I'm going to go backwards, and I'm going to go a little advanced on you. Some of these things I'm going to tell you today, I don't expect you to internalize right now, but I want to tell you them so that when you see them soon in the future, you'll remember like, oh yeah, he said something about that. So if you don't get this, it's cool, but I'm going to show you some craziness now. So let's look at my Linux class here, and we're going to look at the permissions file that I made. Okay, so we've already gone over this RWX stuff. How do I change this RWX? Well, I do it with chmod. This means change mode, which is a bizarre name. After 30 years, I have no idea why they chose this name, but chmod and then the file name is how you change permissions on a file. There are ways of doing this with letters, like saying U plus R, that's user plus read. But what you'll almost always see is what's called numeric permissions. So right here, these numeric permissions we're looking at. Wow, this is not behaving well. So These are binary bits. I don't know if you're familiar with bit masks. I'm going to assume that you are, and if you're not, just memorize the numbers. So the first one's a 4, the second one's a 2, and the third one's a 1. So if I want to set these permissions, I can set them all at once by adding up the digits. For example, I can set R and W with 4 plus 2 is 6. I can set just R with a 4. I can set R and X with 4 plus 1 is 5. I can set all three, R, W, and X, with 4, 2, 1 added together is 7. Now that's for one of the three. So I'm going to give 3 numbers. I'm going to give the number for the owner, the number for the group, and the number for everyone else. And I mention this because you're about to memorize these in the next few weeks as you start doing this. You're going to use the same few of these 1,000 times. You're going to use 644 all the time because 644 gives you, the owner, read and write permission, and it gives your group and everyone else read permission. You're going to use 644 all the time on stuff. The other one you're going to use all the time is chmod 755 on directories, because directories need the execute bit, as my friend here pointed out to me. So 7 is RW and X, I can read, write, and execute my directory, and 5 is read and execute. My group and everyone else can read and execute my directory, which means they can CD into it and use it. So chmod and numeric permissions. If that's too weird for you, do a web search and you're going to find there are other. I just told you about how to do the letter-based version of this, but it's hard to give you all the details in this short amount of time. Google is your friend on this for sure.
Yeah, if you ever Google chmod calculator, one of the first hits you'll get is a little website that you can actually click the checkboxes on what permissions you want. And it will calculate the number for you.
Thanks, Alex. Right, so where are we at here? I'm scared, but are there any questions on the weird numeric permissions? Yes, sir.
3 doesn't show up, right?
Yeah, so this is binary. So binary counts 1, 2, 4, 8, etc. And in this case, it's only 1, 2, and 4. Yeah, so no 3.
You can do 1 plus 2, right?
Oh, I'm sorry, you can. You can for sure.
Makes sense, does it?
It doesn't. And I guess I never thought about it. The logical groupings are a small subset. So like you'll almost never use 1 either. So this is why 644 and 755 are something you're going to memorize. You're going to be using this all the time because it's some of the logical operations you actually want to do. You might do a 775 also or a 664, but 644, 755, you're going to be using those all the time.
It's also logical to have the larger, go from larger to smaller, right? In terms of
Generally speaking, because you want you to have the most permissions and everyone else to have the least permissions. So yes, those are good observations for sure. Yes, sir.
So if you give other group members or just any other people permissions to these files, can they access it and change the permissions that you gave them to not give you permission anymore?
If you give them write permission, they can do anything, including deleting the file. But they can never completely take away your permissions because even with nothing, you can still use chmod to change them yourself because you're the owner, and they can't change the owner, and neither can you. No one can change the owner except for the super user, also known as root, R-O-O-T, root. That's the super user. That's like the administrator on Windows NT, or I guess all versions of Windows now. All right, so next slide. Oh boy, so the find command. This command can be extremely confusing. I've tried to distill this down to the easiest version. And to teach you how to use this, I need to teach you another crazy important concept called pipes. So a pipe is a way of sending the output of one command into another command. So a very simple example of this is if I ls-l this directory, it's huge, it's off the screen. And if I scroll up, there's just all this other stuff, right? Well, what if I want to see that a page at a time? There's a program called less, and less shows me a page at a time. It's a joke because the original was called more, and the program less is a better version of more. It's kind of a joke. It's less, but it's better than more. So the pipe is a pipe symbol. It's above the enter key on your keyboard. It's a shifted backslash, and it looks like that. It's a vertical bar. So we pipe to less, and you can do this yourself, and you'll see a listing a page at a time. You'll see I've got a blinking cursor next to a colon, and I can press the space bar and move down a page at a time, or I can press B and I can go backwards a page at a time. And I want to get out, I just press Q, and I'm out. And I can do it again, and Q to get out. So piping it's one of the reasons to use the command line. This is a way of plugging things together like Legos, or like filters. For example, anybody have any idea how many files and folders I have in there? I have a guess. I think it's about 80. But I want to know how many. So instead of piping it to less, I'm going to pipe it to word count minus L, which gives me the number of lines. So I can run word count on a file and it'll tell me how many lines and how many characters. But I just want to pipe ls through it. Okay, so there's that 62. I've got 62 files and folders. So this is just another example of how you can use pipes. And pipes can be strung together. I can say, see all those Slurm files there? Let's pretend that there are more files named Slurm, and I'm going to look for it with the grep command. Grep is kind of like match this stuff only. So I'm going to grep for Slurm. Okay, and we got those, and I can count that, but let's pretend there's a bunch of them. I can pipe that to WC minus L and know that there are 4 of them. And I could keep going with this if there are more complex things I want to do, like limiting, and then sorting, and then counting based upon the sort, or subsorting, or calculating. There's some really cool stuff you can do with pipes, and I think they're a super important concept. So we're going to use this concept with the find command. So let me let that sink in for just a moment and see if anyone has any questions about pipes. Yes, sir.
Does the order matter?
It does. It is processed in the order you type it. So I typed ls. Let's go back to my example. So I typed ls, and then it went to grep, and then it went to WC. If I reversed the order, it doesn't really make any sense, but we're going to do it anyway. Let me just take away the slurm part. So now it's only counting. It's not looking for slurm. And if I tell it to look for slurm, what do you guys think is going to happen? You're going to get nothing, right? Hey, you're right. You get nothing because there's no slurm in the output from 62. But the other way around, when I look at this giant listing and I look for the word slurm, it finds those words, the words that are there highlighted in red just above it, and then that output goes to WC minus L, which is word count lines, and it's going to count the number of lines, which is 4.
Yeah, pipes work left to right. So whatever is on the left-hand side is the input to whatever's on the right-hand side.
Couldn't have said it better myself.
So it wouldn't make sense to do less pipe ls.
No. You would more less you usually end with. You usually pipe to ls, pipe to less to page it. Less is a pager. It is a page at a time viewer, so it's the last thing so you can see your output. So we're going to apply this to find, and I'm going to show you why. So the find command is like it sounds. It's used to find files. What it does is it spiders an entire directory structure from where you tell it to start. So so we're in my source directory. My source directory's got a bunch of stuff in it. And if I type find and then dot means right here. It means right where I'm standing. I could also give it a different directory name if I really wanted to, but dot is nice because I'm here and I know I want to start here. And if I press enter, oh my goodness, do I get a lot of output. It just goes on and on and on. That's not very useful. What I want to do is look for a particular file. And in this case, I'm going to look for files associated with this, this researcher we used to have, whose last name is Ray, R-A-I. I did quite a bit of special stuff for J. Ray. And I'm going to pipe this to grep. I'm going to grep for what I'm looking for. I'm looking for Ray. And because I know this is more than one page, I'm going to pipe that to less. And here's all the files associated with JRay. You can see I've got JRay move. You can see I've got all kind of JRay type stuff here. And as I go through this, you'll notice that I have, yeah, I'm sorry. Go ahead.
Why do you need to use the find command with the pipe? Because isn't the pipe sort of like a find?
So the find command generates a giant list. And I could look through that giant list on screen by scrolling back. But what I want to do, let's bring it back up. What I want to do is limit the output. So let me demonstrate that. So if I do a find and I pipe it to WC minus L, 15,300 files. I really only want to see the ones named Ray. And how many is that? So let's demonstrate that. We're looking for Ray. And we've got 256 files named for Ray. So I've filtered down my output to only the files that have something in the file name that I'm looking for.
And also, just on that, the pipe command is actually better thought of as sort of a connector. So it doesn't find anything for you, but what it does is you've got a command over here and a command over here, and you want
Connects them
this,
together, yeah.
and you want whatever comes out of here to go into here. So the pipe command is sort of like, you can kind of think of it as like an extension cord. It plugs into here and plugs into here, and whatever comes out of here goes into this next command. It's basically just a series of it's basically just wires connecting commands together.
Hello.
What is the difference between ls and find?
Great question. So ls shows me what's in my current directory or what's in the directory that I specify. So if I have, like, say, 2 folders and 5 files, it'll show me 5 files and 2 folders only. Find does a recursive search through the entire thing. So find spiders everything below me. And if those 2 directories have 1,000 files each, the output of find will have my 5 files, my 2 directories, and the thousands of files below those directories. So it is a recursive searcher on the file system, whereas ls is just a what's right here in this room. Find is almost like what's in the entire tree below me. Yes, sir?
Do you need to have that period there?
Yes. So find needs a predicate. That's a fancy non-specific word. Find needs an argument. Find needs to know what to look in. I generally look in my current directory, and dot in Unix is a synonym for right here. And in fact, you've pointed out something that I didn't say that's super important. There's 2 really special directories in every single directory. We're going to look at them right now. See the 2 at the top? See dot and dot dot? Dot is right here where I'm at. Dot dot is 1 back. So it's your back key. Dot dot is your back key. So if you want to go, let's go back into my source directory, and I pwd to find out where I am. Remember, we talked about where I am, look around, and then go to different places. So I'm in source, but I want to be in Brian Gentry. So I could type cd/gpfs/home/bgentry, and I would be there. But it's much easier to say cd space dot dot pwd, and you can see that I went up a directory. And I can do it again. pwd, I'm in gpfs home. I can do it again. I'm in gpfs one more time. And now I'm going to teach you the home key. This is really hard. Pay attention. cd, enter. And now I'm back home.
If you type cd with no arguments, it will take you back. It's basically like take me home.
Yeah.
It will take you right back to your home directory.
Yes. So that's a really nice shortcut for cd.
So when you use like the less command and it brings up like how you can go through the pages, like how do you like get out of it?
Q to quit. You'll notice a lot of these mnemonics. A lot of the letters that mean the first letter of the word of the action it does. I want to quit, Q. I want a long listing, L. I want to see all files, A. And they're not all 100% intuitive, but I hope that it becomes a way that you remember them, as you can remember the mnemonic based upon the first character of the action that it takes. Yes?
Going back to the less thing, you said a few commands to go through less.
Yeah. Let's do another tour of that because I know that was lightning speed. And I've been using less for almost as long as Unix, so this is a big ugly file. So we're at the very top of the file. If I press the space bar, I go down one page at a time. Very convenient for looking through a long file. If I want to go back, wonder what the key that is. Back, anybody? B for back. So B takes me backwards a page at a time. Why is this not going back? Oh, because the caps lock is on. So page, 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 and then back, back, back. And then, as she asked, Q to quit. There's one more thing you should know in less. And, I'm telling you we're at the top of the file, but how do you know we're at the top of the file? This is a little weird. This doesn't have a mnemonic. Control G. Wrong darn key again. Control G. Control G gives you the exact position in the file. You can see I'm at the end. It's giving me a byte count and a line count. I'm going to go back to the top. I'm just going to hold down B until I get to the top. Ooh, that's a big file. Okay, I'm going to cheat. Control G. And now you can see I'm at 0%. I'm showing lines 1 through 17 of 4,800 lines. And there's a byte count there too. That's sometimes a nice, like, where am I kind of command inside of less. Yes?
I kind of went too much back. How can I get back to my home directory?
Just type CD and press enter, and it'll take you to your home directory. And then PWD to verify, and you should be there.
Yes.
Okay, I feel like I got us off in the weeds just a tiny bit. Am I still on time? Anybody who's keeping track of time?
We are good.
What's that?
406.
I don't know where I'm supposed to be. Am I good?
We are good.
Or do I need to rush? Okay, we're good. All right, thank you. Okay, so we've covered a lot of weird ground here. We did the find command, which you're not going to use find that much, but you'll use it some. And I should tell you one more thing about this whole thing that's very useful. So the grep command is case sensitive, meaning if you type scan, S-C-A-N in lowercase, it won't match that file 6 up from the bottom that it says scan results. So there's an argument to grep minus I. So let's do this. I'm going to ls minus L, and I'm going to look for scan. Oh, darn it. Let's look for results. Results. And I got nothing because results is uppercase in that. If I tell grep minus I for case insensitive, then it finds it. So anytime you're looking for a file that you know some of the name and you're not sure if you capitalize it or not, use minus I for sure. Definitely grep minus I to do a case insensitive match. Super useful. And if you don't use this, you might start to think that grep isn't useful because darn it, I can't match on both cases. Well, you can. Grep minus I. And in fact, it even works weird. I could say grep results in all caps. It still finds it because it's completely case insensitive. Does not match case. Okay. I'm going to move on unless there are Zoom questions. Okay. Oh boy, more commands. So we already covered less, yay. Cat is of limited usefulness, but we're going to cover it. Cat just means dump the file to the screen. So if I cat those scan results, no, that's too big. If I cat this cron file here, oh, darn it, let's find one that actually has something in it. Sorry? I should have done that, but we're going to do permissions. So it just dumps that file to the screen. Cat is only partially useful. What I would normally do instead of cat is I would less the file so that I can see the whole thing and know that it's not going off the top of my screen. Head and tail are very useful as filters. You may want to only see the first 10 lines of the output of ls, for example. So if I do ls minus L, I get this giant listing. If I do ls minus L and I pipe it to head, I only get the first 10 lines. And tail, what do you think that does? Boom, last 10 lines. Now, of course, this is Unix. They all take arguments. What if I want to see the last 3 lines? Minus 3. If I want to see the last 12 lines, minus 12. If I want to see the first 12 lines, head minus 12. So this can be useful when you are sorting results. For example, if you have all the important stuff at the top of this thousands and thousands of lines of listing, you can pipe it to head and just get the important stuff at the top, particularly if you know how many results you need. So I assume you're all data scientists of one sort or another, and culling your data, sorting your data, and then picking the important stuff can be useful. And this is part of the power of the command line, is you can do some of this stuff right on the command line. A lot of stuff that people use Excel for, right here on the command line, that can be done before you fire up Excel, before you transfer the file. So where were we at? We did all these: cat, less, head, and tail. Head's the top, tail's the bottom, less is a pager, and cat is of moderate usefulness. Anything else before I move on? Okay. Okay, here comes the super dangerous stuff. So this is removing files. This is deleting files. As it says in the big box, there is no undo. There is no trash can. There is no recycle bin. Once you do an RM, it is gone. The old thing we used to say 1,000 years ago is sit on your hands before you press enter. Sit on your hands so you can't type and read that command several times. And then pull out your hand and hit the enter key. Just be real careful when using RM because there's no saving throw. You're done once it's gone. RM can take arguments. And this is maybe a good spot to teach you something else that is unbelievably useful, and that is tab completion. So see in the middle of my listings there, I have something called backups. Actually, let's do a batch rsync. So let's say I want to just ls that. If I type ls, and then I start typing BAT, and I press the tab key, it completed it all for me. Anytime you press the tab key in a command line context, it's going to examine all the files and folders that are in your current directory, and it's going to match as far as it can. Let me show you what I mean by as far as it can. If I type B, nothing happens. But if I hit the tab again quickly, tab, it shows me everything that matches. And I go, oh, well, I'm batch rsync, BA, tab. Oh, that's still not enough. BAT, tab. This can save you crazy amounts of typing, particularly when you have crazy file names like, let's see, fruit fly experiments in water. And if I want to ls that darn thing, ls fr, tab, completes the whole thing. So you should be using the tab key all the time. Even when it's short, even when it's 5 characters, you should be trying to complete it with a tab to build your muscle memory of quickly completing all the time. The tab is going to be your best friend, particularly if you're in a research group where they have crazy long file names. I've seen file and directory names that are 30 characters and 40 characters, and they're sometimes nested. But you press the tab key 2, 3, 4 times, just complete it all. It's very useful. So why was I teaching you that? In the context of the RM command. So if you're going to remove something, we're going to rmdir. We're going to remove a directory. We're going to remove this nasty directory I just created, fruit fly experiments in water. So rmdir. And in fact, if I type rmd and tab, it completes commands too. So if you know some of the command you want to type, you can tab that too. So fr, and tab. And there's the whole thing. So it's going to remove my directory, and that directory is now gone. I do an ls-l on fr star, nothing there. So rm removes regular files, rmdir removes directories, and this middle thing is showing you that we can use, I guess it's called globbing. Let's call this wildcard matching. The star means any character. So this middle command would delete any file that ends in .txt. Globbing's a whole thing. Wildcard matching's a whole thing. Just know that star matches anything, and you can get creative with using this. Okay, we've already talked about touch. Touch will create a file if it doesn't exist, or it will set the timestamp on a file. I can't think of good practical reasons you need to use touch. I've used it a million times over the years, but I can't think of a great reason off the top of my head to change a timestamp. But you can if you need to. And of course, you can create an empty file with it. You saw me use mkdir, and you'll notice that this kind of matches up with rmdir because it's 2 characters, the action, and then the word dir. So mkdir makes a directory. It creates a new directory. And you saw me do that back here with make dir fruit fly experiments in water. Move and copy, my old friends. So when you want to work with files, you oftentimes will move and copy them. And they both take 2 arguments, the file to copy and the place to put it. And in the case of move, the file to move and the place to put it. So let's do an example on those.
For what it's worth, you can actually think of move as the equivalent of move in Windows is cut and paste. The equivalent of copy in Windows is copy and paste.
Yes. I saw a question back there.
Is there anything in Playground that they can like test out for copy and move?
They're all owned by me, so no, but they can certainly copy and move right in their home directories. They own all those files. You can touch file 1 or special file or secret file, and you can use copy and move in there. So I'm going to move file 1 to file 100. Move also can kind of mean rename because I'm changing it by doing a move. So mv file 1 to file 100. Now if I ls, I now have file 100 and file 1 is gone. Oh, file 100 is the old file 1. And the same thing with file 2. I can move, actually we can copy file 2 to file 3. We do an ls, and now we have 2 of file 2. One's now called file 3. Very simple, copy and move. You're going to be using those from time to time also.
So when you copied a file just there, did you change the name of it to file 3, or did you just copied file 2 into?
You got it. I copied all of file 2 into file 3. So if you're working with a large data set, say you've got 2 gigabytes of data, and you want to make a copy of it as a backup, is a very common thing before you do something to it. It might take a minute because 2 gigs is a lot of data. In fact, some of our research groups have terabytes of individual data. The individual files are usually never larger than a couple of 100 megs, but even a couple of 100 megs might take a moment to copy. When I say a moment, I might mean 60 seconds. So if your copy hangs, it's because it's big. And you'll know based upon doing an ls-l or an ls-lh for human readable and examining the size.
So now it exists in file 2 and file 3.
You got it. Exactly correct. So I guess, let me just see what's on the next slide. Yeah, I should cover this real quick, and we'll get to the playground if we have time. So you're going to edit files from time to time, and these are 4 of the editors that are installed on the RCC. The first 2 are really the same thing. One is just, Vim is just a newer version of VI, and they're basically identical. I would type Vim anytime you meant VI. VI and Vim are super powerful, really old editors. It's my personal editor of choice that I use everywhere, including on my Macintosh, believe it or not. VI and Vim are amazing. I encourage you to learn them, but there's a steeper learning curve with VI and Vim than even the command line. It's worth saying this. If you're data scientists, you're programmers, you have to think about how long your career is going to be. Are you going to be doing this for 25 years or 30 years? You probably are. And in that time, you're going to edit a lot of files. So at some point, it makes sense to invest a lot of your own time in some editor. If it's Vim, great. If it's Emacs, great. If it's Ultra Edit 32, great. But think about the long term when you invest in an editor. Investing in one that doesn't look like it's going to be around forever might not be a good idea. And some of you might be thinking like, well, what do you mean learning to use an editor? You mean typing? You mean using the mouse? Well, once you start using an editor like VI or Emacs, or even learning the advanced features with the control keys on other editors, you're going to see how much faster you can do text editing tasks. And this is again one of those things where there's this super steep learning curve, and at the end there's a fantastic payoff. of doing wizard-like things with your text files. And again, think forward. Think in a decade when you're editing code. Think in a decade when you're editing or parsing data files. Knowing an editor really, really well is going to be helpful. And VI and Vim are real difficult to start with, but they're super awesome. Emacs is at least as good, at least as popular as VI and Vim. Maybe a little easier to get started with. But for just right now, for just this second, Nano is very friendly. And if you need to just edit a file right now, without all this crazy investment I'm talking about, Nano's your buddy, because you can fire up Nano and it has a little menu at the bottom that tells you how to get out and how to save and other things like that. So it's super friendly. It has almost no power, but it's like driving a Prius. Get in and go. So let me move on here. Okay, so getting help. This is super important. So I'm going to do this upside down. For most of your questions, use Google. If you want to know about if you want to see a tutorial on how to use LS, Google tutorial on Linux LS tutorial. Use Google for a lot of these things. In the past, we would almost always tell people, man, look at the manual page, type man ls, and read about how to use ls. The problem is, manual pages are reference material. Manual pages assume that you already know a lot. And what they really are for is when you already know and you can't remember out of the 35 switches to ls, which one makes the columns go horizontal instead of vertical? Can't remember what that is. You man ls and you look. These are reference pages, and eventually you'll be using them. You'll be happy to have them. But for right now, when you actually want to learn something, Google it. Info is similar to man. That's prettier and navigates better, but it's very similar. It's reference work. You probably don't want to use info very much. And which is a very special case. Which really isn't even a documentation thing. You can try typing which ls, and it'll tell you where ls is located, but it's not all that useful day to day. Occasionally you might be told to use it to find out what version of something you're using, but don't bother with which. Google stuff, and then eventually man it. Okay, so I talked a bit about command history before, using the up arrow to recall your previous commands. This is really nice when you're typing really big commands, or if you want to repeat stuff. You see, I copied file 2 to file 3 here. Let's copy it to file 4. 4. Let's copy it to file 5. 5. Let's copy it to file 6. Let's copy it to file 99. So I can kind of do these repetitive things real quickly. And of course, if you wanted something that you typed 2 or 3 times ago, you can just keep pressing the up arrow until you get to where you want to be. So that's very useful to have. And remember what I said, when you're trapped, press Control C, and you can come right back to where you were. The tab. The tab is your friend. I told you all about tab. Use tab like you're breathing. Use tab all the time. History, I almost never use history, but history will give you a giant listing of every command you've typed since your history was saved. This can occasionally be useful. If you know you did something a month ago, and you know that it had the word JRay in it, then you can type history, and you can grep for JRay. Or you can do history and pipe it to less and page through and look. Oh, that's the command. And maybe it's something very long and complex. And you can cut and paste it out of there. So history can be useful. Oh, look here. We were telling people how to get out of less and man and et cetera with Q. I forgot that one. And then finally, exit gets you out of the CLI altogether. It exits your terminal session and causes you to need to log in again if you want to continue. Okay. That was a bunch of stuff I just spit out. Are there any questions about anything I just covered? Yes?
So there is no command to change the name of the file. You have to create a new file and delete the old.
No, so the move command is like a rename command. Move can rename, or move can put a file, take a file from one directory and put it into a different directory. So move is both a renamer and a mover. It's kind of odd that it's called move, but it makes a certain kind of sense.
And it's like a cut and paste, not like copy and paste.
That's correct. Move gets rid of the original. The original is gone. or it's gone from the original location and the original name, but it ends up wherever you told it to be. Yes?
To log out of somewhere, can you just do exit and then log in?
Yes. Or if you're super, super lazy, Control D. Control D will get you out too, but yes, exit, EXIT. That will end your CLI session altogether. I don't think we have enough time to play around because you've got some more slides to do.
That's pretty much it.
Yeah.
There's one more slide.
Oh, okay. Well then, in our remaining couple of minutes, why don't we go into the playground and let you guys practice. The intention of this is for you to practice doing LS and CD and using the tab. I put some challenges in here that it's going to be a little harder to get into some of these directories using a tab. Of course, you can type them all out, but just play around in the playground. Just CD space playground and do an LS and see what's there and start exploring. Use cat to look at any files that might look interesting. Use CD ... to go back up a directory. And use that tab key, tab. So for those on Zoom that may not actually be logged into an account, I'm going to just play around in Playground myself, and I'm going to show you kind of what I was trying to illustrate. So there's the contents, and if I want to look at this bottom file here, I can do cat. I can just type one character of its name and press tab, and there's the contents of that file. And I can CD into the fun directory. I can CD into other directories. Let's go back. Let's go back again.
So does cat kind of just show you what's in the file?
Yes, it prints it to the screen. In the very old DOS days, it was called print. Very, very much the same thing. Yes.
I have a file that has a space in the name, and when I did cat and I tab, it brought the name of the file, but with the backslash behind it. Is that how you do the spaces?
That is the secret. Is if you need to type a space embedded inside a file name, backslash and then space. And tab completion works after that. So if you do that thing and then backslash space, then hit tab, it'll complete it all the way to the end for you, including any other embedded spaces.
But doesn't use, if you have a space, you don't use quotation.
You can do that too. It's just slower to type. But yeah, quoting in Unix is a whole thing. I can almost do a whole lecture on it. But yes, double quotes and single quotes both work. Thanks for all your attention, everyone, and everyone on Zoom also.
And just as a last wrap up, we the presenters are the FSC Research Computing Center. We're located on the first floor of the Duroc Science Library. The slides and a recording of the video will be sent out by, I think, the libraries a few days after this. They'll put together the video and send it out to everybody who registered for this event. Also on the slides, if you're ever interested, there's this free Linux book called linuxcommand.org. That goes through. That has a little bit of a reference of most of these commands. And if you have any questions after the workshop, or if you ever want to find us, you can always find us at support@rcc.fsu.edu or support@rcc.fsu.edu. Yeah, so that's pretty much the end of our presentation. If you have any questions, we'll be around for another few minutes as we clean up. But other than that, if you have any questions after the workshop, please email us at support@rcc.fsu.edu. And thank you all for attending.